I'm Merris. I'm new to Spec.LA. I'm a student, engineering student, and I like to do photography. I like to do some graphic design, editing. I like to make laser cut jewelry and other things, but that is not what I'm here to talk about tonight. So I have this idea. I grew up gardening in Altadena, and I've always grown my own food, grown my own tomatoes every year, and gained an interest in urban and sustainable agriculture. And I was super intrigued by aquaponics when I found out about it like 4 or 5 years ago, and I thought, wow, like this could totally be a viable solution to our agriculture problem right now. The agriculture industry, as it currently is in America, is totally garbage. It's just not working out. It's totally not going to be able to feed our population. We're destroying our environment, all that bad stuff. I think that indoor farming could totally be a viable solution or a partial solution. I think that if we create aquaponics greenhouses, it would at least alleviate the intensity on the land enough to be able to let the land rejuvenate and revitalize itself, or maybe we could, create our different efforts to revitalize the land while we grow aquaponically and give the land a rest. So here is, so I'm working with David and with other people to design a 3D modeled aquaponics system. So I would want to create an aquaponics system with mostly 3D printed parts. So this is a model of an aquaponics system. Aquaponics is more efficient than modern agriculture. Aquaponics is like hydroponics with fish. The crops aren't water-based, so they aren't susceptible to soil-borne illnesses. It's very water efficient. Since they're grown in such a dense area, it's more like space efficient. You have a higher yield for a smaller space. And so a physical aquaponics system has a fish tank, pumps, filters, pipes, a vertical pump aerator, and grow beds. I'm working on developing this 3D printed system, so I decided that instead of buying styrofoam trays, we would make modular 3D printed squares that snap together so that we could make it larger or smaller depending on the size of the system, and then create like little divots in it for maybe styrofoam to grow in or to go into so that it would float. And So I thought that it would be good to 3D print our own pots. Somebody grab it. Out of flexible material, so that when the plant grows, the pot would be able to expand and accommodate plant growth. Through research, I found out that they have a biodegradable 3D printed material, so I thought that it'd be interesting to try to make my own grow cubes instead of like buying like coconut husks or like pebbles or something like that. Create grow cubes that have the nutrients necessary for plants, like plants to germinate in, water the seeds initially, and then make these grow cubes so that as the plant grows to different stages, it would be able to access the necessary nutrients that it needs to grow into a full plant. And then we would take these grow cubes, put it into the grow pots, and it would be our starter for an aquaponics system. So I found out that there's a company called Spec.LA that now offers 2 different types of biodegradable material. Oh yeah, here's the pot. Here's our CAD design pot. And so they have 2 different types of material, one that's fully biodegradable and compostable, but it biodegrades pretty quickly, so I thought maybe we could use that for the early stages of the grow cube. And then they have another type of biodegradable material that has wood chips in it that maybe could be better for the longer term use. And I found out that felt bags help to get the roots into a root ball so that the plant can grow more vigorously. So maybe creating like a a larger encasing that will help the root ball form for the plants to grow well. So these are the biological aspects that we would need, the fish and the bacteria, and you know, there are different types of bacteria, Nitrosomonas and Nitrobacter are two of them that help to transfer the fish waste into fertilizer for the plants. We would also have to add things like chelated iron, kelp extract, and humic acid to the system for the plants to grow vigorously. This is all great. So there are conditions that need monitoring for a system. A big issue in aquaponics right now is that if the system becomes unbalanced, fish can die, plants can die, you can have an algae bloom, everything can be chaotic. But we could automate these systems so that our computer can tell us and beep at us when it is out of whack, so people only really need to go service the system when repairs need to be made. So there are many systems that can be automated in an aquaponics system, including a pH sensor, electrical conductivity meter, oxygen meter, total dissolved solids meter, nitrogen sensor, ammonia sensor, light control, temperature gauge, temperature control, water levels, pump on-off switch, and a feeder. So if we had this type of system, data points could be gathered and made available through the cloud, and charts and graphs could be generated to show the values recorded over a period of time. Robotic harvesting could also be employed. A robotic armor picking tool could be programmed with X and Y coordinates so that it could you know, sense where a plant is, pick it up, put it into our harvesting container, and this would be really great for leafy green vegetables and herbs. Just cut them from the root. There's currently a shortage of farm workers due to the current immigration laws, and an automated system with robotic harvesting could be a great solution. We wouldn't need as many farm workers. We would need just a few skilled farm workers instead of just tons of people manning the fields who are doing all the basic harvesting. So this system ideally would be modular. So we would start small and then grow it to industrial scale so it could be big enough for supermarkets, probably farmers markets first. Yeah, so the future is now. It's time to start an aquaponics food revolution.